For us to simplify these ratios, there's a few different ways that you can do it, and eventually I will show you another exponent rule, but for now, we're going to expand and cancel. When it comes to the numbers sitting here, if your multiplication facts are a little shaky, you may want to go off to the side and make yourself a factor tree. If you remember like 35, you're like, what are two numbers that multiply together to get 35? And that's 5 and 7, so you make little branches with a 5 and a 7. And then if the 7 could be broken down, you would make branches off of that, but it's a prime number, so that's all we can do is have 5 times 7. So in that numerator, if I expand this, it's 5 times 7 times x times y. 7's a prime number, so I'm going to leave that as just 7. So I have 7 times w times x times y. When there's all multiplication going on, you can cancel. So I'm going to cancel these 7's and the x's and the y's. And what we end up having left over is just a 5 in the numerator and in the denominator w, and we've simplified. Now you can also say to yourself, well, 7 fits into 35 5 times and 7 fits into 7 once. However you simplify fractions is fine, but one way is to expand the number and see what's in common. So when it comes to expanding this one, thinking of two numbers that multiply together to get 27, that's 3 multiplied by 9, and that 9 is 3 times 3. So 27 is 3 times 3 times 3. Again, you could make a factor tree if you need to. The 45 is 5 times 9, and then the 9 is 3 times 3. So that is 5 times 3 times 3 times the x, y, and z. Since we have all multiplication, we can cancel. So I'm going to cancel these 3's, the z's, and a y. And then what I end up having left when I'm done canceling is a 3 in the numerator, and then in the denominator 5 times x, so 5x. Now if you want to, you could think of this as 9 fits into 27 3 times, and 9 fits into 45 5 times. Okay, this one here, if I expand, 2 is prime, so I can't really expand that very much. It's just 2 times m, but the 4 is made out of 2 times 2. So I have 2 times 2 times m times x, canceling the 2 and the m. Everything has been canceled in the numerator, but remember there's always a 1 times here that we don't see. So there's still a 1 in the numerator. So I've got my 1 in the numerator and then a 2 and an x left in the denominator. You could also think of this as 2 fits into 2 once and 2 fits into 4 twice. Okay, and then here's another example. So the number 10 can be written as 5 times 2. Okay, so I have 2 times 5 times g times k. And then the denominator, not much going on there. It's just 2 times k. I cancel what I can, so the 2's and the k's cancel. And again, there's always a 1 times something. So what I have left in the denominator here is a 1, and in the numerator, the 5g. But when you divide anything by 1, you get just itself. So this one simplifies to 5g.